Homework 5, question 2. For the first part, the question needs us to draw a non-zero definition region of f of x and y. And from the question, we know that the y is larger than 1 and x is larger than 1 over y, and also smaller than y. And we can draw the line of this part, these two parts, with this line, and also with y larger than 1. And for this three line, we can know this region is the question asked. And for the second one, we need to find a, so that f of x, y is a valid joint density function. Valid joint density functions means is if we do the cumulate of dx or dy from infinity to minus infinity to the infinity, it is equal to 1. It is equal to 1, so that we can do the cumulate of f of x, first of dx and second by the dy, with the region for dx is 1 over y to the y, for the dy is 1 to the infinity. And the first part, we do the accumulation of dx. We got this part, ln x, from y to 1 over y. And after that, we know that for the dy, we need to do this part. And after calculation, we got this function. And suppose v is equal to ln y, so that y is equal to e to the power of v. And then we can get this function. After the calculation, after the accumulation, we got this function. And for this part, we know that a must be equal to 2, so that this part is equal to 1. So after O is equal to 2. And for the third part of this question is we need to join the marginal density function fx and fy. And also we need to verify fx and fy is valid density function. If we want to know the density function fy, we need to do the integral. We need to do the integral of dx for the f of x and y from the minus infinity to the infinity. And we can get this function is equal to density function of fy. And to verify whether it is valid, we need to do the cumulation of density function from infinity to the minus infinity to the infinity. For the region of y, it is equal to 1 to the infinity, and so that we can know the function. It is quite same with this part. So as a result, in the question 2, we have validated density function of y is valid, so this part is valid. If you want to know the density function fx, we need to do the accumulation of dy of f of x and y from minus infinity to the infinity. So that we need to divide it x to two parts. One part is x in the interval of 0 to the 1, and the other part is from the 1 to the infinity. And for the first part, we need to do the accumulation, and this is the result of this part accumulation. X equal to the distribution function of x, the density function of x is equal to 1 over 2. And for the other part, for the second part, interval 1 to the infinity, we do the accumulation. It is 1 over 2 x to the power of 2, x squared. And when we do this part, we want to know the distribution function. We need to do the accumulation of this function. And from 1 to the infinity, we know it is 1 over 2. And so that for the whole function of density, for the whole density function of x from 0 to the infinity, the accumulation is 1. So the f of x is validated, and this is the function gram of density function x.